going to Twitch, it's just saying it's streaming and then not. So I'm trying to see what's going on with that. Should have been going. If you're seeing this and it's up for you, let me know real quick in the chat so that I can, there it goes. Okay. You're seeing this and, there it goes. Yep. Okay. Finally. Alright, so sorry, I tried a new thing to have the timer up and then restart the stream. That doesn't seem to be working very well. But here we are. So let's go over today's tutorial. So for those of you here, who are here, today's video is going to be going over texturing. This is what we're going to end up with. You'll remember last time we created this room with the mouse controls and the ability to walk around. Today what we're going to do is we're going to add a texture on top of our quad now so that you guys can start rendering your own rooms and such with it. So that's going to be kind of our goal for today is how do you do texturing, what exactly do you use to get it going, and so on and so forth. I want to see something real quick that I'm actually curious about. Yeah, that's what I thought I'd do. Cool. So this is what we have from last time. If we run our video from last time, this is the actual game. The other one I showed is the private game I've been working on. This is what we developed last time, just a kind of quick run around first-person shooter. But one of the things that is very important to this, obviously, is texturing. Right now our room is really hard to tell where the boundaries are, and part of that is just because colors like this don't work very well. And so it'd be nice to be able to go through and texture everything. So, I just realized my camera is in the wrong spot. Sorry about all the delays about this stream as well. I was actually busy with some real world stuff. So there is the camera back in its normal position. So now that this is all ready, let's go ahead and start this. So we want to get a textured quad. Texturing is actually pretty straightforward. The hardest part of texturing is actually loading the images. However, we're going to be able to leverage SDL for this, and as a result we're only going to get one type of image used, but it'll work out pretty well. So what we're going to do is we're going to come over to our drawable. We're going to open up that header file, and then we're going to come down and open up the C++ file. So what we're going to do is we are going to actually add a new method. The first thing that we have to do, so let's step back a little bit and talk about what exactly texturing is, what exactly it does, and what is the purpose of it. So texturing, as you can probably tell from this video, is just in a basic sense adding in an image on top of our shapes and such. So you can imagine in this case I put in a test texture, but other things you could do obviously are walls, floors, and things of that nature. Also note that in this case that the texture background color is transparent. The image, to show what that looks like this. It's just a white background, nothing too special. But if we load this up, what actually ends up happening is that our texture is shown like this. And there's some very specific reasons why on that, which we will go into. And you'll understand why more later. And I can actually real quick demonstrate how to break that if I come over here to this code. I'm not showing this quite yet until it's time. But if I go ahead and I do this, you'll notice that the texture now shows that white color. It's actually, in a sense, inverse, because now our background is shown like this, and the font is now multicolored like we would expect. And you guys will see why that is. This is actually very specifically due to how the shaders play a large role in this. And that's why I've chosen to do some of it. But our end goal is going to look something like this, okay, where we have a combination of the colors from the previous version combined with the texture. So let's jump right in. How do textures work in OpenGL? So if you remember, we have our pipeline. Our pipeline is we call all of our stuff on the CPU, we pass it along, and that gets sent over to the shader side. So what this means is that in order to do this, sorry, people are being inappropriate in the chat. It's kind of bothering me. So let's go start from the beginning. So we have our textures that we're going to be loading in order to get this. So the way that this works is we want to display a texture. So part of this means that we have to pass this along to the graphics card, and then that's going to go through and actually give us some data to work with. So the way that this works is we have to load up our image. We're going to use SDL to do that. SDL is going to load in our image, and it's going to take all that raw data, and then we're going to push that to what's called a sampler effectively. And this is where I'm not as familiar with it. I'm only going to go over it in a very vague sense because of that. But the basic idea is that we push the texture to the graphics card. The graphics card goes ahead and processes it, and OpenGL actually gives us what's called a sampler. We then use that in the fragment shader when we're assigning our colors, which if we go to our fragment shader right here, you can see right here where we have our output color. This will now be used for the texture. So the way that this works is we need to first go through and create a new method in our drawable to actually load up this texture. Now, right now, this isn't the best way to do this. The reason being that the structure of how we're managing our game is not very coherent to this. In this case, the reason why is that we have colored objects and we have textured objects. So generally, if you're going to color objects, you're not really going to throw in a texture with it, and that's where we're going to have trouble because our room is not going to use the texture, only that quad. And so really this is not the proper way. Once we start actually making games and we're using a combination of that, we'll restructure this, and I'll show you guys how to actually make it so that you can easily load multiple shaders and have them be used throughout. So to kind of start things off, though, what we're going to do is we're going to come over here. We're going to do a void load texture method. And all this is going to take in is a string for the file. And this is just going to tell, we're just going to pass in a file name of like what type of texture to load. So now we come down here, we have void drawable load texture string file name. And there's a few parts that we're going to need to do this. So the first thing we're going to want to do is we're going to want to keep track of. Now you remember when we did all of our VAOs, VBOs, and EBOs, our vertex array object, our vertex buffer object, and our elements buffer object, that we also went ahead and we added in, and let me make sure I have this up over here as well, real quick. We also went ahead and added in some other things for uniforms. We need to keep track of where that, effectively it's a uniform, but it's not. It's actually a texture that we're remembering the pointer to, because we need to pass our texture data to OpenGL so it can pass it on to the graphics card. So when we do that, we actually have to create an object for that texture, and then we get a pointer back, and then we populate it with the appropriate data. So in order to store that, we need to create an unsigned integer for OpenGL. We're just going to call this texture ID. And underneath that, we're also going to, again, we're going to use SDL to actually load this texture's data and such. So we're going to take that, and in order to use that, we're going to have up here an include for SDL2 SDL. That way we can have our surface object here. So this is actually going to be where our texture is stored. That's how SDL can store these textures in this case. And so using this is actually pretty straightforward. In order to load our texture, all we're going to do is say this texture is equal to SDL load BMP. And then we're going to pass in the file name. Now remember, SDL is expecting it to be a string array because, again, OpenGL and SDL are built for C. So in this case, we're going to want to pass in this, not the string object. Now, when we do this, we're going to also want to remember later on when we clean up to actually get rid of this texture as well. So what we're going to want to do, an easy way to do this is we come up here and we set our texture. First off, we set our texture ID to 0 because, again, we don't know what that is yet. And now that we have that, what we can do is we can come down here and we can say that if we have a texture ID, then we want to go ahead and clean up our texture, which we do so by taking the texture and doing, actually I think it's release, yeah, that's what it is. So then we go and do SDL free surface, and we pass this in. And that'll go ahead and clean up our surface once we're done using it. So now that we've gone ahead and done that, we can actually go ahead and start utilizing this. So what we're going to want to do is, let me make sure I'm seeing everything properly. So now that we've gone ahead and done that, we want to make sure, first off, if this texture, so that way we make sure that our texture was loaded. And that might be a better way to do it down there. You could also do it like this. The main reason I'm doing it like that is because that's just easier for me, and there's some other cleanup that we're going to want to do associated with that. And realistically, if our texture doesn't load the image here, we don't want to actually create a texture at that point. We want to just continue on and be like, okay, you didn't load the image, we're not going to create anything else for you. So, but if that's successful, then what we want to do is generate the textures. And so right here, what we're going to do is we're going to generate one texture, and we're going to pass in, remember, we're passing in our texture ID as a pointer, but what it's actually doing is it's a list of textures. So if you were generating 15 textures, you could change this to 15 and have a list of textures that you would then pass in instead. In this case, we're just doing one. Again, we'll focus on efficiency later. The key for this first set of tutorials and the first parts of all this is to get everyone used to how do you do this in OpenGL. The efficiencies will come later, and we'll kind of discuss some of this because a little bit of what we're doing to get our shaders to work is not going to be as efficient as it could be. So once we've done that, again, what we want to do is we want to check that our texture ID is set to something other than 0. We can do that by just checking whether or not it was set properly. So now that we've done that, what we need to do is we need to now bind the texture. And the reason for this, and I'll explain it once I type this out so I can also explain the method. So remember with our shaders that we had to go through and we had to bind the shaders we're using, we had to tell it, we're using this shader, we're using these elements. Textures are the same way. We need to tell it which texture we're using, and we can use multiple textures for that as well. In this case, you'll notice we're using texture 2D. That's because textures can actually, there are multiple types of textures. There's 1D textures, there's 2D textures, there are also 3D textures. I haven't really used a whole lot of 3D or 1D textures, but the basic premise is that there's different data associated with them. Really, I'm not going to go into that. That'll be saved for future stuff if we decide to go over that. 2D textures are all that we're worried about because, again, we're just trying to display our images onto it. So now that we've bound the texture there, what we want to go ahead and do is actually load in our data. So we're going to call GL text image 2D, and we're going to pass in a few things. So I'm going to go ahead, I'm going to type this out, and then we're going to go through each section, and I'll explain what exactly it is we're passing in. And some of this will be pretty obvious, like the W and H right there is obviously width and height, but then you start getting into things like these random zeros and GL, BGR, and GL unsigned byte, and then finally this texture pixels. Okay, so that is quite the method there. So let's go ahead, I'm going to bring up the documentation. If you're watching this if you're watching this on YouTube, you'll be able to see all of this in the description below to get a hold of it. So this is the method we're using. It's quite a doozy, but it's actually pretty straightforward. You're not really going to generally modify a whole lot of it. So the first thing is we have our target. In this case, we're targeting the texture 2D that we gave before. Remember, we just bound that texture 2D for right here. So when we target our buffer, we're going to be targeting that texture 2D as a result. Next, we have level. So level is the detail number. And this is a little bit of a trickier one. It's related to mipmapping. And in this case, we're not going to worry about it. We want to keep it at the base detail level. I'm not really going to go into that a whole lot right now. There's other things you can read about online, and honestly, I'm not all that concerned with it. It's affecting how it'll look, and it'll look fine with what we're doing right now, so I'm not going to go into the details of this. We will explain mipmapping briefly after we get the basic loading going, but I'm not going to go into all sorts of crazy details right now. Next, we have the internal format, which for ours, if you look at this, we send it to RGB. RGB obviously stands for red, green, blue. And so in this case, what we're saying is that we want to pass this along to OpenGL as red, green, and blue, because those are the types of values we're giving. Another one you can do, as you can see here, is RGBA. So if you have transparent pixels, you can go ahead and pass those in as well, and that'll work. So that's that. Next, we have right here the width and height. This is pretty straightforward. It's the width and height of the image. However, there's a key thing for performance and such that you really want to focus on, which is all of your width and heights should be powers of 2. So if you're going to do a texture, you want it to be 256 by 256 or 512 by 512. This is just a good way to do it. It helps keep everything. There's some performance and stuff behind the scenes, which I'm not going to dive into. It is important to do, though. Next, so I'm going to continue on from there. That's the key, though, is just width and height. Border specifies the width of the border must be 0. So just keep that at 0. Don't worry about it. Format. So this is the internal format that is available, and this is the format of the texel data, and I think actually I don't think it's a huge deal. I think you can change this around a little bit. Let me try real quick. I feel like there's one they're actually missing on there that's not listed. Either that or it just doesn't matter. Yeah, it doesn't really matter. But basically this is similar to up here with the internal format. Basically this is the format of the texel data. So you'll notice that when we let me think of how to explain this. So the internal format, when you load the image data in, all that OpenGL sees is a bunch of data. It doesn't know how that data is organized. It just knows it's there. So when you pass that in, you have to tell it specifically, hey, this is, the first value is going to be the red, the second is green, the third is blue. So that's when you pass in the data for the internal format. But for this format, when we're actually getting our data into our shaders, now we need to specify what kind of format is there. So what this basically means is when we pass our data into our shader, we're going to be accessing those colored elements in a certain way as well, and so this format specifies it. So if you just say that it's RGB, all the data that you're going to get is just going to be RGB. If you see RGBA, it's just going to be red, green, blue, alpha for colors for transparency. So that's what that's specifying. Next up, we have our type. So this specifies, and you'll notice here, that we pass in BGR. Really, I'm going to make this correct because BGR isn't an accepted one in this case. It should be red, green, blue, and that's what we're passing in. So next up, we have our type. So this is the type of data that's being passed in. You can see that there's only a few specified values. So you have unsigned byte, which is basically each one is 8 bits, and that basically means that when we pass that in, we're expecting 3 values, each of 8, 8, and 8. You can also go through and do some other things like 5, 6, 5, so each one has a max of 5 at 6 and 5. This would also be 8 for alpha. The other one is you can do 4, 4, 4, so half the value is 5, 5, 5, 1, so on or off. Generally, you're not going to worry about that too much. You're just going to stick with unsigned byte, and that's all there is to it. However, we'll kind of discuss that with our image here when we start actually getting to how to export that. Finally, we have a pointer to our memory. That's just the data, which in this case, we used unsigned byte, and then we just pass in this .textures pixels. So basically, with SDL surfaces, that's how you get that raw data for the image. Okay, so that's kind of a hefty one. So now that we've gone ahead and done that, what we're going to do is finally, I'm going to go through what most people would do in this situation just so everyone can kind of get used to it. We are skipping a step now. We're going to go back to it, but I think it's important that you see what can go wrong so you know how to fix it. So what we're going to do finally is we need to bind a new texture because we want to get rid of using our current one in case we load another one in the future. So if we do any new texture stuff, it won't affect it. So we just bind 0 because 0 means that it's an invalid texture. That's why we can do this check right here. So this will go through, this will load our texture and get it set up. So now that we've done that, what we're going to do is we're only going to use this. We're not using it on the room cube, which is our room. We're actually just going to use it on test shape right here. And this is actually pretty straightforward, but we do need some new data. So you'll remember that previously, and I'm going to separate this out a little bit better so everyone can see it. So we have our actual vertice points. So we have -0.5 and 0.5. So this is the top left corner, then we have the top right, then we have bottom right, and then we have bottom left. So now what we have here is we have our color data. So we have red, green, blue, and then white. So then now what we need to do, now that we've actually gone through and started adding in textures, we need to tell where exactly the texture coordinates are. These are called UVs. So basically the way to think of UVs is we have our, is this it? Nope, whoops, wrong one. So test shape, and then, sorry, I'm trying to open this up as well so we have this ready to go. So the way to think about it is that we have our quad, okay? So we know that this is the top left, this is top right, this is bottom right, this is bottom left. Now remember, that's all we knew is where those points were, so we added in colors. So those colors specified, okay, this is this color, this is this color, this is this color, this is this color, and then it blends them all together. Based on that, when we go to our fragment shader, when we retrieve those colors, it blends all those in. So now that we've got that, we need to add on our texture. So we know that we have our textures data with our shader. However, we don't know exactly what each portion of the shape's color should be. So for example, we know that in the case of our texture here, we have this text texture which is 512 by 512. So I'm going to go ahead and select that so you can see. So that's 512 by 512. So how do I know that at this corner, okay, that corner should be white? And how do I know at this spot right here that that should be black? How do I know that? This is where UVs come in. UVs are basically coordinates that specify at each vertice what part of the texture maps to that, and then it kind of blends all of that together. And we'll get into that blending process in a little bit here, but that's the basic way to think about it for the time being. So we need to tell how the texture kind of stretches over the shape. So what we have to do is we have to tell basically what the coordinates of the texture are. Now these only go from 0 to 1. You can make it 0 to 5, and that does some stuff. And we'll talk about that, we'll show that as well. But for now what we're going to do, for our top left corner, because that's our top left, that's just going to be 0, 0. Our top right, as a result, because it's on the right side, is going to be 0, 1. I'm going to go ahead and also separate that out. So now our bottom right, as a result, would be a position of 1, 1, and our bottom left is going to be 0, 1. So that's basically the coordinates for the texture. It's pretty straightforward. Top left, top right, bottom left. And that's all we have to do outside of adding another 8 vertices here, because now all of our vertex data actually contains 8 additional points. Now there is some other stuff we're going to have to adjust, the first of which is obviously that our attribute pointers are now going to be separated by 7 elements instead of 5 because we've added 2 more. The color attributes can actually remain the same, however, because the vertice data was added to the end of each one. So now that we've done that, what we need to do is we need to add in a new value, which is UV attributes. So what we need to do is we need to do this UVAT is equal to shader get attribute UVs. So we'll just call it UV. So now that we've done that, we need to then enable those pointers for each of these as well. So we come here, we do that. In this case, we only have 2 attributes. They're still floats. they're still going to be not normalized. We're also still going to keep everything separated by 7. And then here, they're no longer the second one. They're actually going to be the fifth one, because we have 5 elements that come before them, the last 2 of which are elements are going to be our UV attributes. So we've gone ahead and done that. Only thing left now is we need to come down here and say this load texture. And we're just going to call this test.bmp. Okay, so now we've got our test texture loaded. This will go through and set it up with that shape. Let's go now and migrate over to our shaders. So this is where things get a little trickier. So we have the test vertex shader and the fragment shader. So I'm going to switch sides of which sides these are on, so this will hopefully make things a little easier to see and understand. So we have to do, remember, it passes through our vertex shader first, then it goes through into our fragment shader. So when we go into the vertex shader, we need to go ahead and have this be a vec2 UVs. That way we can go ahead and take those in, because that's what we specified them as right here. And actually that should be UV. And that's why it's always good to check that. So now that we've done that, we want to have an output of vec2 UVs. And all that we're going to do is we're basically going to set UVs equal to UV. And basically all that does is that sets the output here to the fragment shader for that. So we're now going to have an input vec2 UVs. So that'll go ahead and be retrieved from here. So now that we've got those, what we want to do is we want to blend in these colors with each other. Remember, we have the color from the texture and the color from the actual shape that we've been passing in previously. An easy way to do this, which is very straightforward, is we simply take, so first off we need to create a temp color. This temp color is really just going to be, and let me make sure I type it right, is going to be a vec3 temp color is equal to color, and then all we're going to do is add on that by doing plus equals texture here in texture, which we'll get to in a sec, UV RGB. And we need to come here and we just do uniform sampler 2D in texture. And that'll go ahead and let us select that one texture and be able to blend the colors together. So we've gone ahead and we've done that. We've got our UVs passed in here. We've got our texture going on there. At this point, I believe we can go ahead and run it and we'll see something happen. I'm not going to say what. I'm not going to say whether it's correct. Let's go ahead and we'll build it. We'll make sure we don't get any compilation errors. I'm watching everything over here to make sure it's the same. We go ahead, we do this, builds everything up. So now we go ahead and we run it, and we get undefined variable UV uppercase. So where is that? Well, that was going to be, if we come here, and we see this, we'll see that this is declared in our fragment shader. So it's complaining here that in our fragment shader UVs is incorrect, and that is because I incorrectly did that. So let's go ahead and try that again. Okay, so we go through, we do this, we see no texture, we see absolutely no change in our shader really. Why is that? Well, first of all, there's no shader that's been passed in. That's the first key. The second thing that's going on is if we go through, we need to save this. So let's go ahead and make our texture now, because I completely forgot that step. Hello there, KillAA13. We've got our texture here. All it is it's a white background with some text on it. So we're going to go ahead and export this, and I'm going to put this down into Visual Studio 2015 projects, demo project, and then I think we just are keeping everything in here currently, correct? Let me just double check. Show all files. Where's our shaders? Let me find where our shaders are real quick. So these are located in the demo project. Yeah, okay, so these are just located in here. So we're going to save this as test.bmp. So we export that, and you'll notice the first thing that comes up. I prefer GIMP, but other programs will be a little bit different on this. The first thing you'll notice is that it's selecting automatically 32 bits R8, A8, G8 B8. So let's go ahead and we'll export that. I'll show you what that's going to do. So let's load this up again. Still nothing. What did I do wrong here? So we have this, we have this, we have our test state, which is taking in all that. We are using that. Test shape is taking in these. Let me make sure that this is getting into here, okay? Make sure that all of that is being read properly. I'm kind of confused because I didn't see that, actually. So, yeah, okay. Let's see here. And there's our UVs, yep, okay. So there's that. Well, either way, you'll notice there's no texture right now. Generally, the reason for this is because if you go ahead and you export it like so, you need to make sure that, as I said before, we're using 8 bits per color. We're not using an alpha, so it's important to do that. If we go ahead and we run this now, you should see that it is not displaying anything still. And we need to come over here. I want to make sure that all of this is right. That exports our colors there. We have that. And then our fragment shader has our uniform sampler there. Let me just double check everything here. We have our texture loaded there. Whoops. Where did I go wrong? I did something. There's some kind of typo I'm making here. I know it's something silly too. That's the sad part. In Vec2 colors, okay. We're giving 2 there. Getting all that, that's all correct. We're loading our texture. Well, we're buying that. And then coming over here, we have all that, which is remain the same. I don't think we need to enable any texture 2D stuff, do we? That could be it. GL enable. Need to though, because I thought that this was already done. I could have sworn this was already done elsewhere, so let's see here real quick. No, see, that's not it. So, and this isn't complaining about any compilation errors. Out vec4 in UV2, okay, in texture UVs. RGB temp color plus equals that. Oh, that would help as well because it's probably compiling it and not even showing it. Oh my gosh. It's been one of those days, guys. I am so sorry. Okay. So there's that. We have our temp color there. That's being output. Vec4 out color in texture. Let's go ahead and just go do this to start. That should come out with absolutely nothing, which is pure total darkness. So you'll notice that there's nothing showing there. And what we can do, though, is if we go ahead and we show this, this is, so we see that there's no colors here. The reason for that is because we are still getting these colors from here. The reason our texture is not showing up, and this is a very key thing, it's actually a huge pain to debug textures in a sense, but the reason that this is not showing up is because our shader cannot figure out how to actually interpret the colors from those fragments. Remember, we have a fragment shader that's doing all of this, and so in order to actually utilize that, our fragment shader needs to be told what exactly it should do in between. So remember, we specified each corner what the colors are, but we didn't specify anything in between. So OpenGL has to kind of vaguely interpret that, and so we have to tell it how to do so. So what we're going to do is we're going to use the text parameter I. We're going to set it to the target of this to be a texture 2D. And what we're going to do is, first off, I'm going to bring up, and this again, if you're watching on YouTube, this will be, in the description of the video. But if you come in here, we've got this. So the first thing we specify is the target. Again, this is texture 2D in this case. And then we have the parameter name, pname, which is basically one of a few things. We have the texture min filter, texture mag filter, and texture wrap S and wrap T. So min filter is when we're minimally filtering these colors and such, what should we do? And then the maximum, what should we do? This is complex to explain. I'm not going to get into it, but the best way to think about it is that there's 2 points at which it takes a sample, and depending on how close and far and all sorts of other things, it does it differently. And so we specify, we tell it which parameter we want to adjust, and then we tell it how to actually handle that. So what we're going to do in this case, and there's a great picture I'm going to pull up in a second, is we're going to use, first off, GL texture min filter, and we're going to use GL nearest. And we're going to do the same thing for mag, which is, again, it's a little tricky to say. So now if we go ahead and we do this, it should come up perfectly fine. Well, ish. It's going to look weird still. Why did that not come up? That should have. Let's see here. Where's that fragment shader? Doing something wrong with passing in this texture. We load our texture there. Do I need to have that? No, that should not need to be done. Let's double check this real quick. Make sure that this is actually getting generated. So we generate our texture, we go through, we do all of that. Okay, let me just go ahead and make this simpler BGR so we can see some difference. That should have been working. Oh, duh, okay, I completely forgot a step. I know exactly what I forgot. My apologies, guys. It's been a slow day. Okay, so remember, we had to bind our texture here. We also unbound it. So whenever we draw our object, we still have to rebind and unbind it. Same thing. So now what we want to do is do GL bind texture. And this is going to change some stuff around, so I'm going to, again, remove these filtering so you can actually see what it'll do if you don't have it as well. So we're going to do GL texture 2D, and this texture ID, and then 0, and then undo this so I can copy that down again. There we go. Okay. So now if we run this, what you will see, now that that's all set, is again nothing until we come up here and we do this. In which case, it's all loaded. However, something's off about the texture. You'll notice that our colors there are not quite right. So let's restart this first of all. So what we're going to do is, to start out, we're just going to pass in that texture color instead. So only thing it'll get is a texture color. If you do that, you get the texture working perfectly, but we don't see any of our colors. The reason for this is that we're not actually using them when we output the color. That's why what we do is we take in the color and then add on that texture. We can also, of course, do it this way, which might work a little bit better for showing. So let's do it that way. So if we just use the texture color, all we get is our texture image. We don't see anything else outside of there. In fact, if we come out, we can see our walls in our room, but we can't see the colors with it. So that's why what we have to do is we add on the colors. However, if we go through and we add on the colors, then everything looks weird here because we get that white, but then our text doesn't show up right. So why is this? Well, basically what's going on is that we're adding the colors to it, but the biggest, if you max out the red, green, blue values, all you get is white. That's why when we do that, we're just getting a white color there, but the other values, the black values, get added onto our color values like normal. So black has a value of 0, 0, 0, but our colors are like, 256 and other values, 128. There are other values for our colors because we're passing that in. So when we add those together, we're just getting the normal color instead of a black color. So an easy way to fix this is to go ahead and multiply it. So if we go ahead and we do that, we get kind of an inverse effect. Now our text shows up correctly, but the background doesn't, which for me is actually okay. I don't actually want our background to show up with those colors right now. An easier way to fix this as well would be to just make the colors white or black and then add or multiply accordingly. Pretty straightforward fix, but I actually like this better and I want to have this for that tutorial. So once we go ahead and we do that, now that we have these colors set up, the other thing to notice, however, is our background is gone. Our building is still gone. So how can we fix this? And this is where you'd want to actually end up using two shaders, and you would use a different shader each time as a result. However, in the case of this, we want to keep it more simple. Sorry, my phone is ringing, so I want to finish this up before I make any more calls. So once this is all finished up, now what we can do is we want to go through and have a way to kind of activate and deactivate the colors. So what we're going to do is we're actually going to have another uniform right here. We're going to have a uniform bool has texture. And basically, if this is true, if we have a texture, so remember before we had the code like this, the reason why is that we're going to have a uniform bool has texture, and if we have a texture associated with this, then what we're going to want to do is actually multiply the colors in then. That way it'll actually take the texture color into effect. Otherwise we don't want to. So now we need to pass that in, but we only want to pass it in for the objects that have textures. So we actually need to go over to our test state, and we need a value to track for this. So the first thing is we have to get that uniform, so we need to have this be, let me just double check everything again. So we want to have a value glint has texture uniform, and this is just going to store that uniform value. So now we come over here, underneath our shader, we're going to do this, shader get uniform location has texture, and this will be set to that. So now that we have that, what we're going to do is whenever we draw the room, or whenever we draw our test shape, so for our test shape, gl set uniform, and before we do that, we also need to go through and include gl slash glue, which should be at the right order, I think. Right? Oops, wrong order. And remember, because of the order of how OpenGL does things, we need to make sure we include that first. So once we've done that, now when we come down to our update method, if we do this, now what we want to do is GL uniform 1i. So we're passing in, remember, a boolean is just off or on, it's just an integer value, so all we want to do is pass that in, and we're going to set it to true for here, and then we're going to render our room, so we're going to set it to true there, and then we're going to set it to false when we draw our room. When we draw our shape, it should be true, and when we draw the room, it should be false. And now if we go through and we render this, what you'll see is that for our room, it only uses the color, and for our text, for our actual quad, it uses the normal texture. So this is kind of a basic rendering tutorial, texturing tutorial. It's a very straightforward thing. What we're going to do now is we're going to go into some of the more advanced stuff. So if you're looking for just a basic throw a shape on a wall, this is a pretty good way to do it. However, there's a couple problems. So if we go up really, really close to this and we look at it, you can kind of make out these lines along the side. And it just doesn't look pretty up close. Now you'll remember that I said when we went to our load texture method, okay? Let me pull this onto the right side as well. So we come over here to our drawable, to our load texture method. You'll notice that we used nearest as our filtering method for these. The reason why is that that's just kind of the standard one to go to, but there's a couple other ones that you can use. And I'm going to pass this link in the description of the YouTube video as well. If you want me to put it in the chat, I can, but this is it right here. This kind of goes over some of that, and it kind of shows the different types of filtering and how they work. So the next step up that you can do from there is linear filtering. So if we go through, to do that, it's pretty simple. You just do linear, and oops, and that'll go ahead and switch everything. So if we go ahead and we run this, you'll actually notice instantly that once we get close to these things, they look much, much nicer. Suddenly, all those jagged lines that were there are now gone. Everything just looks way, way smoother. But there's still actually a problem. If you go far enough back, so we'll go right to the edge, and you look at it, when you move the mouse around, it kind of gets this this pixelation, this fuzziest look. And the reason for that is that far away, the texture is now kind of blurring together weirdly. And so what we want to do is we want to fix both of those. Now remember I said that this is the minimum distance and that the maximum is elsewhere. The maximum is that bottom one. So the way that this works is that we really want to have our maximum filter be linear, but our minimum filter should be a little bit different. And this is where things get a little trickier. But basically we want what is called mipmaps. You can also do anisotropic filtering. I'm not really going to go into that though. Mipmapping just looks a little bit better in my opinion, for reasons obvious. And they both have their own problems. Basically, you can read it right here. If they're too far away, it looks bad in one section. If it's too close, it looks bad in another section. So what we do is we do mipmapping. So mipmapping, as you can kind of see right here, basically you start with the normal image and you shrink it by powers of 2 until you only have a 1x1 image, which is basically the average of the entire image. You then, depending on where you are and when what you're drawing and how far away and all that, you draw the appropriate with the appropriate image based on that. Who is messaging me? Yeah, min is minification, mag is magnification. So basically, when you're far away, you're using min. When you're close, you're using max. Yeah. So I want to say that anisotropic filtering uses, and this is where it gets tricky because there are game development settings for this. This is where it gets so complicated, and this is why I'm only going at this on a basic level. Ray March said, I thought anisotropic filtering is an improvement of mipmapping. It's trickier than that. Basically, anisotropic filtering is one way of doing it. And anisotropic filtering, you'll use it in combination with mipmapping. Mipmapping is a part of this in a sense. And this is where it gets so anisotropic. Yeah, I'm terrible at pronouncing this stuff. Basically, anisotropic filtering it's another type of filtering that can be used with mipmaps. You can't just use linear and such alone. You want to use it with this mipmapping. And so mipmapping kind of helps to improve the level of detail you get from it, if that makes any sense. In game development settings, you'll generally see the multiple types and such. You'll have your setting for 8 times, 4 times, all that stuff, and yada yada yada. It's a little bit more complex than that, but basically you end up using this in combination with mipmaps. And if you look here, when we use it, there's actually a setting for linear, mipmap, linear, because we're using both of those. But the basic idea is that you have multiple versions of your image that you use, and then you add in that filtering combined with that type of image to get a clearer result. So basically, if you're really close to an image, you want the biggest version of that image, and then when you sample it, you want to sample it nicely still. That's why if we look at our code right now, if we come back to this and we get up close with our linear filtering, everything looks nice. And so when we go through and we do this, what we're basically really doing is we're making it so that when we're close or far away, it'll look better depending on basically once we get this once we get close to it, it'll start then using a bigger mipmap and then using that linear filtering with it. And I'm not going to go over combining all the different types. We're just going to kind of keep it simple right here. And again, adding in this filtering is super, super simple. So for our min filters, what we really want to change, our minification, we want to then change that to linear, mipmap, linear, and that's going to go ahead and tell it to use mipmaps. However, if we go ahead and we run this, it should not show anything pretty. Should actually show it pretty ugly still, or nothing. Yep. So notice when we do that, we get nothing. That's because, again, remember, we're actually using technically multiple textures. We're using all of the textures going down divisible by 2 until we get that 1 by 1. So we need to actually generate that. And it's actually super, super simple. OpenGL is really nice in that it does that. All we have to do is call GL generate mipmap. And then we give it our target, which is GL texture 2D. And this is something I just got this pointed out to me. I actually didn't know this. I don't deal with it as much, but anisotropic filtering, hope I'm pronouncing that right. I really apologize if I'm butchering that. Is not supported. Is supported, but on all is it's core OpenGL, but supported on almost all GPUs. Basically, there are some GPUs that don't properly support it. I did not know that. OpenGL is a little fragmented sometimes with that. It's part of the core, but it's not always supported as a result still. But yeah, so basically what this is going to do, this is going to generate our mipmaps for us. And now if we go ahead and we run it, you'll be able to very, very quickly see. Oh, it's not core OpenGL. Sorry, it is not core OpenGL. That's why it's not supported on all the graphics cards. This guy, my friend here, is keeping an eye on me to make sure I don't tell you guys anything wrong. Basically, anisotropic filtering is not a core feature, and so certain graphics cards might not have it as a result. So you can use it, but it might not always be supported. The OpenGL variant of anisotropic filtering is improved mipmapping, right? I'm not actually sure on that. It might be better in some ways, but you still want to use mipmapping with it as a result, as far as I know. So this is, the big thing is the core feature versus non-core feature, which I think is actually more important. But I believe, I can do a quick search on that real quick, but I believe it is not. I really don't want to go over anisotropic filtering right now in OpenGL because I've done it a few times and I remember running into it before. Because before I got this computer, I had a huge pain with it. I believe that, let me see if I can find it real quick. I haven't done it in a while, so I did not prepare for that. So let me see if I can find something on it real quick on how it's done in OpenGL. Yeah, you need the extensions for it, so I can't really go over that right now. Oops. Is it directly calculating the filter based on the dx and dy of the fragments? Yeah, it automatically goes through and calculates that. OpenGL kind of handles that on its own. That's why it's considered not a core feature. It's an extension, and so each graphics vendor implements it on their end, and then we just ask the graphics card to do it for us effectively. So yeah, basically the filtering is generally done on the graphics card, and so that's up to the graphics vendor. That's why it's not a core feature, because each vendor has to go through and implement it, and so really it's not a whole lot extra on us. I just have to find the correct sequence of commands and all that to call and make it do it. And that, I didn't really prepare for that because, again, I think that this will look just fine for what we're doing. We could go into much, much more detail, but I don't really want to right now, so sorry about that, Ray March. But to kind of demonstrate what this does, so remember, before when we got close, it didn't look so good. Now if we get close, you know, it still looks pretty fine. None of that weird blurring. And if we get further away, once we get to the edge here, I can move around and it does not look bad still. So we can see everything still looks good. Yes, so every OpenGL feature, yes, but there are some features which are essential. So like mipmapping, for example. Mipmapping is guaranteed to be so the extensions are implemented at a driver level, I believe. I forget the exact details of how it's done, but basically each graphics card vendor adds support for the individual graphics cards, because you got to remember, OpenGL is still higher level than what we're actually doing. We're still not talking directly with the hardware. We're still talking to a driver, which then talks to the hardware. And that driver does a whole bunch of stuff that we don't see. So for example, GL Generate Mipmap probably has some implementation stuff that is affecting lower. Same with the texture parameters here. I haven't actually looked into how they're created. That's something that I haven't really had much of a need to. Maybe in the future we can go over that, and I'll read up more into it. But that is up to the drivers themselves, to the vendors themselves. So I can't unfortunately answer that. Unfortunately. So, but yes. So this is the basics so far of rendering textures. That is true. That is very true. Tuger. If you don't support a core OpenGL feature, yes, and that is why I'm gonna mispronounce this forever. Anisotropic filtering is not necessarily supported because it's not a core feature. I missaid that. I was mistold on that. It is not a core feature, and as a result, it is not guaranteed to be implemented by each driver. So, supporting OpenGL, they are technically if they don't have it, because it's not a core feature. So, so this is the basics for how to do texturing. Now, I did want to cover something. I don't know if I have time or if I have the materials to do so at the moment. Let me check real quick. I wanted to show you guys how to do seamless texturing really simple. So let me find out if I have an image of this. I do. Yes, you guys are in luck. So let me go ahead and bring this up. Download this image. That'll hopefully be okay for it. Okay. And I'm going to read from the chat real quick because Tuger is explaining some stuff. So he says, and this is good information to know, if you don't support a core OpenGL feature, you cannot say supports OpenGL. If you say you support OpenGL, you have to support all the core features. And this is key because remember, I said specifically that we're using, I think OpenGL 3.2 was the version we decided on. And that means that all of the features we want that we're using here will, if your graphics card supports OpenGL 3.2, it is guaranteed to work with this, because of the fact that it's all based on core features. Yeah, and other thing is there's an implicit in a reasonable amount of time in there, because in theory you could implement everything in software, it would just be ridiculously slow. How is it done in real time? I'm seeing those mentions. So there's a discussion going on in the chat. It's kind of more out of my league now, just because I don't have all the info on it. So Ray March, that's a good question. I can research that and I can try and have an answer maybe by next weekend. So I'll try and do that, and I'll let you know unless Tuger is able to respond now and has an answer. I'm not entirely sure on the solution to that myself. So for the time being, so now let me go ahead real quick and I'm going to bring this image over. So I want to show one quick thing that's actually super useful to be able to do, I think. So what we're going to do is we're going to open up from here. I'm going to come into here, projects, demo project. Okay. So one of the big things that is very useful to be able to do is to be able to create textures which are seamless. And this is something that is a little tricky to do, but it's actually not too bad with GIMP. Graphics cards are awesome. This is actually only the first graphics card I've ever had, and basically before this I couldn't do anything, and so actually having one and being able to do all these cool filterings and stuff is really awesome. So real quick, I want to bring up this image. You'll notice that it is it's just a picture of my bathroom sink tile, the countertop. And what I want to do with this, and this is something that's really neat to be able to do, is I want to take this and I want to be able to seamlessly put it over. So if we were to go ahead and we were to do this real quick, so I'm going to show you guys something cool. Remember how I said that with our tiles and such, how, well, yes, we have, so these values right here, from 0 to 1 is our min and max of our x and y. Now if we go ahead and we do something weird, such as making this 5, we're going to get something weird happening. So remember what it looked like before, where it's just all over the image. Now if we go ahead and we do this, you're going to see something really weird looking. You're going to see it says test texture, text texture. It's repeating across. The reason why is we've now specified that from the left to the right is actually a 5. So basically 5 textures can fit within the width of that image, and then 5 can fit in the height. So it goes ahead and repeats. And you can actually configure it to either repeat or to stretch, depending on some of the, if we go into here, into our drawable, we come down, we can actually, there's other texture parameters, texture parameter I's, and you'll remember I mentioned those right here. So we have wrap S and wrap T. Wrap S and wrap T can be set up to clamp to edge, mirror repeat, or just repeat, and what that'll do, so clamp to edge basically says maximize it, make it use up the full space. Repeat basically says repeat, which is what it does by default. So right now it's just repeating like this. So let's go ahead real quick, and what I'm going to do is I'm going to take this texture and I'm going to extract just part of it. So let's go ahead, we'll say size, and it's going to be 2988 by 2988. We'll go ahead and we will take out that image section. And then, now that we've got that, I'm going to go ahead and make that to the edge. So there's that. Now if we do this, we'll copy, paste it as a new image. So here is our new result. Oops, not quite there. I need one more to the left. Right? 2988, 2988. So now let's go ahead, we're going to scale this down because again it needs to be a power of 2, so we're just going to make it 512 by 512 like before. So there's our image. So let's go ahead, we're going to export this. We're going to do this as test2.bmp. Hi TTGG1. Yeah, those, I'm not sure on those. I've never seen those before. Those might be related to it. I need to look into it more. I'll research that and I'll try and, yeah, I'll get back to that later. So let's get into this texture. So we've got this new texture right here. What I'm going to do is we're going to load that up, and you're going to see something weird with how it comes up. So let's go ahead. Where's our test state C++ file? Test state right here. Whoops. Okay. So right here we loaded in, whoops, we wanted test shape. Whoops. So we're going to load in that test shape too. And now if we go ahead and we load this, what you're going to see is you're going to see something really ugly. Remember, we're repeating the texture, and if we go ahead and we do this, and I'm actually going to go ahead and get rid of the colors. So now we're just going to set it equal to the texture color. So it's only going to use the texture if it's there. So when we do this, it looks really, really awful. It does not blend together well. It's a mess. And we can actually go ahead and we'll make this test shape, and we'll make this, so there's 555. We're going to make this, should be okay actually. So there's our test BMP. Actually we need to export this with the correct colors, so we'll do that. There we go. Now if we load this up, it'll look really ugly. So that is what that looks like. It's just a mess. And there's a very specific reason why on that. Does that work? Yeah, there we go. So that's what our textures look like. It's just a mess. And there's a very specific reason why. That's because those edges don't go together yet. So we have our texture there, but you'll notice it doesn't blend together. This is a cool thing to be able to do. It's very simple, but it's actually very useful. So with this texture, basically what we want to do is learn how to make a seamless texture. It's a pretty straightforward thing, but I figured I'd go over it just because this is useful, and it'll be helpful to those who are looking to make some basic test little test games with it. So what we're going to do is, the first thing we're going to do is we're going to resize this, and then we're going to do image. We're going to basically make it, what you'll notice I did was I scaled it so that we can now fit 4 of these images on here. So it's 1024 by 1024. Our image size is 512 by 512. If you're using GIMP, then you just go up here and you set fit layer to image size. And that's going to go through and scale that. So now what we want to do is we want to actually add this image, and we're going to then set it up to be offset by 512. We're going to basically, actually what I'm going to do to make this easier, we're going to come to configure grid, we're going to set this to 512 by 512, and then we're going to do view show grid, and then we're going to do view snap to grid. So what this is going to do is this is going to let us make a seamless texture. So what we do is we take this texture here, we take this image, we copy it, we paste it, and then we move it over to the right here. When we move it over to the right, what we're then going to do is go to Layer, Transform, Flip Horizontally. And what that's going to do is that's going to give us that. Now what we do is we take it again, we're going to bring it down here, and we're going to flip it again, but this time we're going to flip it vertically. I don't know why it's doing that, but there's that. Finally, we're going to take it, we're going to move it to the bottom right, and we're going to flip it both horizontally and vertically. And then we're going to put it back there. And now that we've got all those there, we're going to export it. And this is actually a cool little trick to be able to see it a little bit better. However, you'll notice that while it works up and down, it doesn't actually work left to right still, and it very much looks repetitive. And so the final thing we're going to do is we're going to go to Filter, we're going to go to Map, and we're going to go to Make Seamless, and that's going to go through and that's going to do some magic to actually make it look a little bit better. You can still see, however, that it's a bit textured together. So usually what I'll end up doing is I will actually go and make this seamless before I actually